Okay, this lesson is introduction to finding inverse functions in chapter 6. I'm sorry. This a little bit of the graphing and just a little bit of introduction. We'll get a lot more into this when we get into graphing. But this is kind of introduce inverses. So here's the main objectives: be able to write an inverse function, understand how it works from one to the other, be able to graph that function and see the relationship back to the original function, and be able to show that two functions are inverses of one another. So let's just start really simply here. Okay, what is an inverse? An inverse is where you start with the equation y is equal to x. Okay, and that's the identity function. And notice for every y it equals to x. X and y are interchangeable. So if I switch out the x and y, every time I see a y, I replace it with an x, and every time I see an x, I replace it with a y. You literally switch the equations. You have the same equation. So here, what I have here is this green line, and that's the identity function for inverses. Okay. So let's take a look to see what this means for us. F of x is equal to 5. Well, that is equivalent to saying y is equal to 5. To find the inverse, and the way we show that is f negative 1 of x, okay? And this is not a negative exponent where it's in the denominator. It's just notation to show we're finding the inverse of the function. You replace the x's with y's, okay? So what's going to happen here is this. We're going to start with y is equal to 5, and then you replace it with x is equal to 5. You literally change your x and y's. So now the function x is equal to 5. So let's go back, and this is the inverse. And the original function is this one right here. Okay. So let's graph the original function in red. So y is equal to 5, which is a horizontal line going through the point 0, 5. Okay. Now let's go ahead and graph the inverse function in blue. And that's x equals 5, which is a vertical line going through this point here. Notice the two intersect on the identity line. Okay. Also notice the points here. 0, 5, this is x, y. If you switch the ordered pair, now the 0 becomes the 5, and the 5 becomes the 0. You literally switch the values. So if I found a point over here that was negative 3, 5, then the point on the blue line by switching the values, 5, negative 3, which is going to be right down here. So those 2 points are inverse of one another. I'm literally just switching the x and the y's. Okay. So what we have here is basically reflected image over the green line. If I took the red line and flipped it over the green line, it would end up as the blue line. Okay. So we could say that f of x and f inverse of x, they're inverses of one another. Okay. So let's take a look at this example. So to find the inverse, I'm going to switch, first put that to y. This way we have a variable to work with. And then we're going to switch the x and y. So I'm going to put x in y's place and put a y in x place. I'm just going to go back in and fill in the letters like that. So notice all I did was switch it, okay? And this is the inverse portion right here. Now, again, we can't graph it that way, so we have to solve for y. So what I'm going to do is move the 3 over to the other side, and we have x minus 3 is equal to 2y. Divide by 2, and we get 1/2 x minus 3/2 is equal to y. And I'm just going to move this over and show it like this, so it looks a little normal. Okay. So the f inverse of x is equal to 1/2 x minus 3/2. So notice all I did was switch it, and then I have to put it back into a graphing form. So let's graph these 2 lines. Again, in red, I'll graph the original function, 2x plus 3, 1, 2, 3. We have a slope of 2x. Okay, and notice I'm going to keep going and get a nice clean line here. Now, just looking at what I have here, I'm just going to guesstimate on some of these points. Notice this point right here is 0, 3. So I know my inverse is going to have the point 3, 0. And notice it is going to intersect where it touches the inverse line. okay, the identity line. And let's just take this point right here. This point over here is -4, comma, 2, 4, 5, -5. So if I switch those values, I'm going to be at -5, comma, -4. So go back -5, -4, and that's going to be my inverse point. Okay. Now if I connect those lines, it should be the line 1/2 x minus 3/2. So let's go ahead and do that. So 1/2 slope is going to look like this. And notice it falls right on line with what we wanted. Put arrows on our lines as needed. Okay. So notice those two lines are inverse with one another. Okay. So 1/2 x minus 3/2. So notice we have a y-intercept of 3/2 right here. We're across the y-intercept, and we have a slope of 1/2. So those are two perfect examples of lines that are inverses of one another, and they're mirror reflections of each other on the identity inverse line. All right, so let's take a look at this one. It's a quadratic. Okay, so let's go ahead and graph this function. We know that this is going to start here, and over 1 up 1, over 1 up 3, over 1 up 5. Okay, and we're going to have the same thing over here with negative values. So let's go ahead and take a look at what this looks like. So if I'm going to graph this, and let's just highlight some points here. So this point here is 1, comma 1. All right. This point here is 2, comma 4, and then 3, comma 9. Okay. So if we switch the points over, we should have the point 4, comma 2, and we should have the point 9, comma 3. As well as the negative side. So let's just pick out one of these points. -2, comma 4. And we're going to go over to 4, comma -2. So all I'm doing is switching the x and y values. So let's go ahead and graph this function. Okay, so notice I didn't have to look at algebraically what the function looks like. Now, let's go ahead and take a look at this function. Y is equal to x squared. Now let's go ahead and switch the x and y. So that's what it looks like. Notice all I did was switch to x and y. Now we have to solve for y. So we talked about this in our last lecture about solving. How do you get y by itself? Well, you take the square root. You have to undo the square term. So notice when we're taking the square root, we're doing the plus and minus. So we have y. All I'm doing is putting y on this side now. Y is equal to the plus or minus the square root of x. Okay, and this equation, and again, I probably should have done in blue. So this is the blue line. Okay. Y is equal to plus or minus the square root of x. That is the inverse function. Okay. So if I was to show it, I would show f inverse of x is equal to plus or minus the square root of x. Okay. And we'll talk later on about is this a function, yes or no, and why. But that's a different lecture. Right now we're just getting down the algebra and what it looks like on the graph. Okay. All right, so on this one, I'm not going to ask you to graph it because we'll get to that in our lecture, but I do want us to find the inverse function. So let's go ahead and first put a y in its place. Then let's go ahead and switch the x and y values. So notice, put an x there and put a y there. Okay. Now, just like in our last lecture, we need to isolate the y. So I'm going to move the -1 to the other side. So we have x minus 1 over here, divided by 2. So we have 1/2 x minus 1/2. And the last thing we need to do is then take the cubic root. Now notice, we're taking the cubic root, so we keep the same sign. So we're finding the cubic root here. And I'm just going to put it back in this order. Y is equal to the cubic root of 1/2 x minus 1/2. Okay? Not the prettiest equation, but 1 nonetheless. So my final statement should look like this. F -1 of x is equal to the cubic root of 1/2 x minus 1/2. Okay? And those would be inverses of one another. Okay? So the next thing we're going to show is how is this equation and the inverses, how can we show this? Okay, so we're going to show you with a different equation here in a second. So let's take a look at this one. How do we show that the inverses algebraically are the same? Well, if we go with this theory, f of x, how does that compare to f inverse of x? Well, if we nest one into the other, so if I say f of the inverse of x, this should yield x, okay? Because what is this? This is the identity function of y is equal to x, which is f of x is equal to x, okay? The line where x's and y's are the same. We could also flip it, and by saying f inverse, find the inverse of the original function, and this should cancel each other out and become x itself, okay? So we're going to take a look at that here, okay? So let's do this one over here first, okay? So what I'm going to do is say, okay, 3 input minus 5. And what am I going to input inside the equation? And we'll do this equation in blue and this equation in green. Here I'm going to put 1/3 x plus 5/3. I'm nesting the inverse into the function. Everything should cancel out, and we should get x left over. So let's see what happens. Distribute the 3, and we have x. Distribute it here, and we have plus 5, and then a minus 5 on the outside. And notice those two cancel each other out, and we're left with x. Okay? So the inverse nested into the original functions cancel each other out. Let's take a look over here on this way. So now on this side, I'm going to start with the inverse, 1/3 of input plus 5/3. And I'm going to input the original equation of 3x plus 5. All right, so let's go take a look here what happens. Well, 1/3 times 3x is just x. 1/3 times 5 is 5/3. Okay. And what am I missing here? Oh, this should be a minus 5. Oh, wrote down wrong, so let's make that correction. Sorry about that. Okay. So then we have minus 5/3 here, and then plus 5/3 on the outside. So notice, let's just eliminate that, and those two cancel each other out, and we're left with x. So being that these two things reduce to just x shows that they are inverses. Okay, so that's one way algebraically to show it. Obviously, we can see it on the graph, but algebraically, notice we didn't graph anything here, and that's what it looks like. What I want you to do is try a couple runs. First, take this equation here and graph the original equation and graph the inverse. And then down below here, I just want you to find the inverse function. So here we give you x to the 5th power with a coefficient in front. Find the inverse, what that looks like.